Hello there, people. I hope you guys are doing super well and are in the best of your health and spirits. My name is Bhoomika, and today I will be guiding you, mentoring you, facilitating you in the insightful journey of exploring the math section of the JEE main paper, which was conducted on the 25th of Feb in the second shift. So, what exactly is on the plate today? See, today I will systematically present to you the solution to each and every question of this respective paper. Mind it, you guys, the solutions that I will be sharing with you are the most efficient ones because they carry the smartest methodologies, the wittiest techniques, and some of the most speedy approaches to conquer a particular question. Okay, so if you are someone who had taken this very attempt of the JEE main paper but could not perform up to the mark, and hence you're planning to sit for the future upcoming attempts of the 2021 JEE main exam, then this video is tailor-made for you, trust me. And undoubtedly, you will be finding it extremely useful and immensely helpful. So without any further delay, let's dive right into the discussion. Now, we all are aware that this paper was conducted in the online mode. So you were supposed to take this paper by sitting in front of a PC. Also, the total time allotted to you to complete this entire paper was 3 hours. Now, this paper consisted of 90 questions, 30 from each subject, physics, chemistry, and math. But the good news is, out of these 90 questions, you were only supposed to attempt 75. How did this entire thing work? Let's understand. See, 90 questions divided into 3 subjects gives you 30 questions per subject. Now, each group of 30 questions you divide into 2 sections, Section A and Section B. Section A consists of 20 questions. Each one of them is MCQ type. That means each question consists of 4 options, exactly one option being correct. If you tick the correct option, you get +4. If you tick the incorrect option, you get a -1. And if you leave the question unanswered, you get 0. So there was a negative marking of -1 in Section A. Yes, whereas if I talk about Section B, it consists of 10 questions. Each one of them is of FIB category, that is fill in the blank type. So there is a statement along with a blank. You have to fill that blank with the correct numeric value by using your mouse and the virtual keyboard. If you give the correct answer in Section B, you get +4. If you give the incorrect answer or you leave the question unanswered, in both the cases you get 0. That means there is absolutely no negative marking in Section B. Moreover, out of the 10 questions of Section B, you are strictly supposed to attempt any 5. So what do you get? 20 questions from Section A, 5 from Section B. That means 25 questions per subject, which makes it 75 questions for you to be attempted in the paper. Alright, so this was all about the paper pattern. Now, let us inspect and scan in detail the behavior, the nature of the math section of this paper. See, for convenience, I have divided the entire ocean-sized syllabus of mathematics into 5 distinct units, which are your algebra, coordinate geometry, trigonometry, calculus, and the remaining additional topics. Now in here, this green colored portion that you can see along each bar is simply representing the number of easy, straightforward questions that were asked from each unit. So can you realize a good number of questions in the paper were asked which could be solved in the snap of a finger. Now, if I show you this another color, which is extending along each bar, this is actually representing the weightage of moderate level questions from each unit. Okay, the questions which were not so straightforward, not so simple and direct to crack. And lastly, this dark colored portion that you just saw along the bar of algebra, coordinate and calculus is representing the number of questions from these respective units which were on a difficult end and pretty challenging to conquer. This was the distribution among the easy, medium and difficult level questions across the units. If I individually catch hold of the algebra unit, then how was the number of questions distributed among all its chapters? Let's find out. So you can see there were 2 questions, both of moderate level, asked from matrices in Section A. Also, there were 2 questions from sequence in series, one in section A, other in section B. But the one in section B, which was of an FIB category, was, as you can see, pretty challenging to conquer. Okay, rest, you can see majorly the questions were from easy to medium level only. Moving ahead, let us explore the behavior of the next unit, which is coordinate geometry. So in here, there were 2 questions which were very, very challenging to crack. One from 3D geometry, other from vectors. Whereas the remaining ones, all of them belonged to majorly the easier category. Okay, we will check out what actually made these questions difficult in our discussion, which is going to follow. Moving ahead to the next unit is trigonometry. So trigonometry actually presented 2 questions, one from ITF and one directly from trigonometric equations. Both were fairly simple to answer. Okay, let's move ahead and talk about the biggest unit, one of the biggest units, because calculus and algebra, you know, are the fattest units when it comes to the syllabus they contain and the number of concepts they possess. So if I talk about calculus, this was the distribution of the questions across the chapters. Exactly one question was there which was very burdensome to crack, and that was from definite integration, right? Whereas if you look at the remaining questions, all of them are belonging to easier to medium level. Okay, that was the good news. And lastly, if I talk about the miscellaneous section, which consists of 3 chapters, probability, statistics, and mathematical reasoning. From here, there was absolutely no question asked from statistics, whereas 1 question was from MR, extremely simple. 2 questions from probability, again, extremely straightforward. If you knew the concept, it was just the task of a snap of a finger to crack them. Now that we are through with analyzing the behavior, the nature of each of the units in the math section, let us move ahead and talk about this. So how was the paper distributed among the 11th and the 12th grade? You can easily make out 60% of the paper was from 12th grade syllabus and 40% of the paper was from 11th grade syllabus. So roughly I can say that the paper was, yes, pretty well structured and balanced, but majorly it was concentrated towards the easy and the medium level questions, and lesser it was concentrated towards the difficult level questions, which was great news for the students. Now that we are through with proper in-depth scanning and inspection of the math section, let me bring you the very first question of this paper. Belonging to the family of 3D geometry, here is the question from planes. It says that there is a plane which is passing through 3 points A, B and C, and you are aware of the coordinates of each of these 3 points which are sitting on this plane. If O is the origin and P is the point 2, -1, 1, then we are supposed to find the length of the projection of the OP vector onto this plane. Fine. So you have to interpret the language of the question. First of all, there is a plane on which we have 3 points sitting, A, B and C. We are aware of its coordinates. A is 1, 2, 3, B is 2, 3, 1 and C is 2, 4, 2. Now the very first thing which should pop up straight in your mind is that if you have a plane with the coordinates of 3 points known to you, then you can successfully find the equation of that plane using what rule? Can you recall? So if I treat this as x1, y1, z1, this as x2, y2, z2, and this as x3, y3, z3, then the equation of this plane comes out to be determinant of x minus x1, x minus, or I should say, y minus y1, z minus z1. This is x2 minus x1, y2 minus y1, z2 minus z1, and here comes x3 minus x1, y3 minus y1, and z3 minus z1 equal to 0. When you solve this determinant, what you end up getting is the very equation of this plane. So you know the role of x1, y1, z1 is being played by the coordinates of A. The role of x2, y2, z2 is being played by the coordinates of B. And the role of x3, y3, z3 is being played by the coordinates of C. So just plug in all those values in this determinant. What you end up getting is this. Fine. So this is the very determinant that we will be solving in order to get the equation of this plane explicitly. So let's start. I am going to obviously expand this determinant along the first row in order to solve it. So what I get in the next step, this will give me x minus 1 into minus 1 plus 4 minus of y minus 2 into minus 1 plus 2 plus z minus 3 into 2 minus 1 equals 0. I did nothing. I just basically expanded the determinant along the first row. Cool, sorted. Let's resolve this now. This will give you x minus 1 into 3 minus of y minus 2 into 1 plus z minus 3 into again 1 equals 0. Fine, basic calculation. In the next step, you get 3x minus 3 minus y plus 2 plus z minus 3 equals 0, which eventually gives you what? 3x minus y plus z. And then minus 3 plus 2 gives you minus 1, minus 1 minus 3 gives you minus 4 equals 0. Bingo! This is the equation of your very plane. So the very first step you would have easily made out was to derive the equation of the very plane about which we are talking in the question. Now, there are 2 points that we are concerned with, O and P. O is origin and P is some point whose coordinates were known to us, right? First of all, try to check whether the coordinates of O and P are satisfying the equation of the plane or not. You will realize that in place of x, y, z, when you plug in 0, 0, 0, the left-hand side is not equal to the right-hand side and hence origin does not lie on the plane. Similarly, when you plug in the coordinates of point P, which are 2, minus 1, 1 into the equation of the plane, it will not be satisfied, thereby implying that both origin and point P are sitting outside the plane. Fine. So this is going to be my OP vector. I want to find the length of its projection onto this plane. So what is the drill? Basic common sense, okay? The drill is that you drop perpendiculars from O onto the plane and drop perpendicular from P onto the plane. Fine. So OO dash is perpendicular to the plane and PP dash is perpendicular to the plane. Obviously, both O dash and P dash, which are foot of these two respective perpendiculars, will lie on the same line L, which is going to be a part of this plane. Obviously, when you project the OP vector onto the plane, what you get is the O dash P dash segment. So if the question is to find the length of the projection, indirectly the question is asking you to compute the length of the O dash P dash segment. That's it. And we know as a matter of fact that if we have a segment with us, okay, and we are aware of the coordinates of the endpoints, we can use the distance formula to get the distance between them, which is basically the length of that very segment. So in here, the hint you would have already got. I am interested in getting the coordinates of O dash. I am interested in getting the coordinates of P dash. Okay, what is O dash? It is the foot of the perpendicular drawn from O onto the plane. We know the concept. If I treat this as x1, y1, z1, and the equation of the plane is ax plus by plus cz plus d equals 0, then what will be the coordinates of O dash? Can you tell me? Do you remember? If I say O dash has coordinates x2, y2, z2, then what will all this setup satisfy? x2 minus x1 upon A equals y2 minus y1 upon B equals z2 minus z1 upon C equals minus of ax1 plus by1 plus cz1 upon A square plus B square plus C square. Yes, easy peasy concept. Cool then, plug in the values. x2 is as it is, x1 is 0, A is nothing but 3. That is coefficient of x from the equation of the plane. y2 I won't disturb, y1 is 0, b is what? Minus 1. Z2 I won't disturb. Z1 is again 0. C is coefficient of Z, which is 1. Then you have minus of AX1, that is 3 into 0, which is 0, plus BY1 again 0, plus CZ1 again 0, minus 4 upon A square, that is 9, plus B square plus C square. Okay? Nothing rocket science till here. Cool. So you get x2 by 3 equals minus y2 equals z2 equals 4 by 11. Now you know x2 by 3 is equal to 4 by 11 gives you x2 to be 12 by 11. What about y2? It will be minus 4 by 11. And what about z2? It will be simply 4 by 11. Bingo, you have the coordinates of O dash with you. Exactly in the same manner, we are going to compute the coordinates of P dash. All right, so let's start. Run now, this is x1, y1, z1, and this is x2, y2, z2, and again this is ax plus by plus cz plus d equals 0. So if x2, y2, z2 are the coordinates of the foot of the perpendicular drawn from point P onto this plane, then what is the relationship which will be satisfied? Again same, x2 minus x1 upon A equals y2 minus y1 upon B equals z2 minus z1 upon C equals minus of ax1 plus by1 plus cz1 plus d upon A square plus B square plus C square. Plug in the values. So x2 as it is, x1 is 2, A is 3, y2 as it is, y1 is minus 1, b is minus 1. Z2 as it is, minus z1 is 1 and c is again 1. Minus of ax1, that means 3 into 2, plus by1, that means minus 1 into minus 1, plus cz1, that means 1 into 1, plus d upon a square plus b square plus c square. Sorted? Cool, then when you will simplify this, equate this with this, what you will get is x2 as 10 by 11. Equate this with this, you will get y2 as minus 7 by 11. And equate this with this, you will get z2 as 7 by 11. And this is how you will get the coordinates of even P dash known to you. You have the coordinates of O dash, you have the coordinates of P dash. You know what to do. Just apply the distance formula and you will get the length of the O dash P dash segment. That's very, very simple. What you have to do? Positive square root of 10 by 11 minus 12 by 11 whole square, that is difference of x coordinates whole square, plus difference of y coordinates whole square, plus difference of z coordinates whole square. Okay, simplify this. What do you get? You end up getting root 22 by 11, which on simplification simply gives you root 2 by 11 units. So the length of the O dash P dash segment is these many units, which is representing nothing but the length of the projection of the OP vector onto this very plane, which is the answer sitting in option C. Bingo, you're done. The only two concepts that were required to crack this question. Number one, you should know how to write the equation of the plane when you are aware about the coordinates of 3 points sitting on it. And number two, how do you find out the coordinates of the foot of the perpendicular drawn from a known point onto a particular plane whose equation is again known to you. These two concepts, if you were aware of, this question would have been a cakewalk for you. Next up, we have this question from mathematical reasoning, superbly simple, superbly easy. It is giving you an if-then implication here as the statement, and it is asking you to compute its contrapositive. So, the only concept you require to crack this question is that if you have an if-then implication, it will look like if P, then Q, which you write as P implies Q. In here, P is your antecedent and Q is your consequent. So, a P implies Q statement. Its contrapositive is given by what? The contrapositive is the statement described by negation Q implies negation P. Remember this? If this much you can recall, this question is a child's play for you to crack. So, in here, the role of my antecedent is being played by you will work. And the role of consequent is being played by you will earn money. That's how my given statement is an if-then implication. If P, then Q. If you will work, then you will earn money. So its contrapositive will be negation Q implies negation P. So for that, we will have to decode what is negation Q and what is negation P. So if P represents you will work, negation P is going to negate the assertion made by P. So negative of you will work will be what? You will not work. So negation P is nothing but you will not work. Fine? Or you won't be working, or you will not work, or you won't be able to work. Depending upon the context, you can just negate the statement P and write its negation. Now Q says you will earn money. So negation Q will be what? You won't earn money. That is, you will not earn money. Cool? So now we need the contrapositive, which is negation Q implies negation P. That means if negation Q, then negation P. That's the contrapositive that I need to frame. So it will be what? If you will not earn money, then you won't work. If you will not earn money, then you won't work, which is sitting in option A very comfortably. Tick it, correct option, you're done. Coming from the world of quadratic is this very interesting question. It says alpha and beta are two real quantities and 1 minus 2 iota happens to be a root of this very quadratic equation which involves alpha and beta as its coefficients. Then, out of the given four options, which represents the correct value of alpha minus beta? Obviously, in order to compute the correct answer of this question, we should first of all decode the explicit value of alpha and beta individually. Then plug them over here in this expression and compute alpha minus beta. Alright, so I am running behind alpha and beta, isn't it? Now, there are two very nice approaches to tackle this question. Number one, see, 1 minus 2 iota is a root of this quadratic equation. That means, in place of z, when you plug in 1 minus 2 iota, this equation will get satisfied. So let's do that. In place of z, just plug in 1 minus 2 iota. So this is what you get. Absorbed? Digested? Cool. Let's proceed ahead. Now, 1 minus 2 iota whole square simply gives you 1 minus 4 iota, no doubt, plus alpha minus 2 alpha iota plus beta equals 0. So from here to here, we can very smoothly reach. Yes? Okay. What you have to do next is realize one thing. On the left hand side, when you resolve, you can actually get a particular complex number. So how? Look over here. 1 minus 4 is minus 3 plus alpha plus beta. Or alpha plus beta minus 3. Club them together. This is real part. And minus 4 iota minus 2 alpha iota. Minus 4 iota minus 2 alpha iota. This is the imaginary part which on resolving gives you minus iota into 4 plus 2 alpha. Yes, so my left hand side actually dissolved to be a complex number which I wrote in the standard format of x plus iota y, wherein x represents the real part and y represents the imaginary part. Now, this complex number x plus iota y is equal to 0. This is not 0, this is actually 0 plus 0 iota. So left hand side is a complex number, right hand side is a complex number. Two complex numbers can be same if and only if their real parts are equal and their imaginary parts are also equal. So equate the real parts, equate the imaginary parts, you will get two equations, you simply have to solve them. So when you equate the real parts, you get alpha plus beta minus 3 equals 0. And when you equate the imaginary part, you will get minus of 4 plus 2 alpha equal to 0. That means 4 plus 2 alpha equals 0. Okay? You have two equations involving alpha and beta. You have to simply solve them to fetch alpha and beta. So from this equation, you can clearly deduce that alpha will be minus 2. Plug that value of alpha in this equation. What do you get? Beta is nothing but 5. The moment we have the individual values of alpha and beta, plug them in the expression alpha minus beta, and what you end up getting is minus 2 minus 5, which is minus 7. This is your answer. As I said, this is first way to tackle this question. Now, another very interesting way to tackle the same question is by using a very important concept. We have learned that when you have a quadratic equation with all the real coefficients, mind it, each coefficient has to be compulsorily real, then in that case, if that quadratic equation has complex roots, they will always occur in conjugate pairs. Right now, we have the quadratic equation in complex variables such that each coefficient is real. Did you notice in the question it was given alpha and beta are real? So coefficient of z square is 1, which is real. Coefficient of z is alpha, which is real. And the constant term is beta, which is real. So we are 100% sure that each coefficient sitting in this quadratic equation is real. And one of the roots of this equation is 1 minus 2 iota, which is a complex root. That means other root will obviously be the complex conjugate of it, which is 1 plus 2 iota. Yes, so let's say this is small a, let's say this is small b. So small a and small b are roots of my given quadratic equation. Then I know the relationship between roots and coefficients. Sum of the roots is minus of coefficient of z upon coefficient of z square, and product of the roots is constant term upon coefficient of z square. Plug in the values of a and b. What will you get? 1 plus 2 iota plus 1 minus 2 iota equals alpha. This gives you 2 equals alpha. Alpha is known so simply and quickly. And alpha into beta. So multiply both these quantities, you will get 1 plus 4 iota square, or I should say 1 minus 4 iota square equals beta. Iota square is minus 1. This simply gives you 1 plus 4 equals beta. That is, beta is 5. Isn't it? Am I right? So in here something is wrong. We should get alpha as minus 2. Why am I not getting alpha as minus 2? Because sum of the roots is minus of coefficient of z upon coefficient of z square. So a plus b is minus alpha upon 1. So that is how you get alpha as minus 2 and beta as 5, which were the exact same values we were getting here. And now alpha minus beta hence comes out to be minus 2 minus 5, which is minus 7. Both the approaches are super simple. Whatever clicks, you can use that and tackle this question. Easy. Coming up next is this question from definite integrals. It is giving you the expression for in and asking you to compute the relationship between three terms, I2 plus I4, I3 plus I5, and I4 plus I6. So which out of the given four options is representing the correct relationship between these three terms is what you have to find. Now realize in here that 4 is nothing but 2 plus 2, 5 is nothing but 3 plus 2, 6 is nothing but 4 plus 2. So this is giving me the hint that I should in general compute the value of in plus in plus 2 for every natural number n. Because once I get the value of this expression, I can compute n equals 2, I will get the explicit value of I2 plus I4. Then I can compute in here n equals 3, I will get the explicit value of I3 plus I5. Then I can plug in n equals to 4, I will get explicit value of I4 plus I6. Once I have the explicit values of each of these three terms, I can then observe them and very easily land up to the relationship between them. So you've got the drill. My strategy is to find the value of the expression in plus in plus 2. Okay? So in we know is integral pi by 4 to pi by 2 cot raised to the power nx dx. In plus 2 will be nothing but in place of n here you just write n plus 2. So this will be integral pi by 4 to pi by 2 cot of n plus 2x dx. Okay. So this in the next step gives me integral pi by 4 to pi by 2 cot to the power nx plus cot to the power n plus 2x whole dx. Okay? In both these terms, you can see cot raised to the power nx sitting commonly. So I'm interested in extracting it out. So this will give me integral pi by 4 to pi by 2 cot raised to the power nx. Inside I'm going to have 1 plus cot square x dx. We all know 1 plus cot square x is nothing but cosec square x. Yes? So this is my final expression. Now it's very simple to crack this integral, isn't it? We know differentiation of cot is minus cosec square. So what I'm going to do is I am going to take cot x as t, method of substitution. So minus cosec square x dx will be dt. Okay? Also, what about the limits? If x is pi by 4, then cot x will be cot pi by 4, that is 1. And if x is pi by 2, then cot x, that is t, will be cot pi by 2, that is 0. So this eventually boils down to 1 to 0 t raised to the power n minus dt. Okay? Now to adjust this minus sign, what I can write this as alternatively? 0 to 1 t to the power n dt, which is t to the power n plus 1 upon n plus 1 with limits from 0 to 1. So this is nothing but 1 upon n plus 1. Bingo! We have very successfully deduced the expression of in plus 2 for every natural number n. And now you know the next step. When I plug in n equal to 2, what I get is I2 plus I4 coming out to be 1 upon 2 plus 1, that is 3. When I plug in n equal to 3, I will get I3 plus I5 coming out to be 1 by 4. When I plug in n equal to 4, I will get I4 plus I6 coming out to be 1 by 5. 1 by 3, 1 by 4, 1 by 5. Tell me. They are in AP, they are in HP, they are in GP. What is the relationship between them? We know that 3, 4 and 5 are certainly in AP. So from here I can say that reciprocals of these three terms, which are 3, 4 and 5, are in AP. Yes, so 1 by 3, 1 by 4 and 1 by 5 will be in HP. Let's observe the options. Now we don't have the option regarding harmonic progression. So option B is definitely correct, which is saying reciprocals of each of the three terms that you were interested in are in AP because 3, 4 and 5 are in AP. You're done. Easy, right?